Welcome to our second episode of Hashtag Trending, the Weekend Edition's AI series. I'm your host, Jim Love. AI today. There is a pattern for the adoption of every new major technology innovation that enters the world of business. And this pattern was first observed by an analyst for the Gartner Group in 1995. Her name was Jackie Fenn, and I've had the pleasure of meeting her. Jackie is quite matter-of-fact in describing her discovery, which some would put into the category of a Moore's Law type of observation. She called it the hype cycle. The hype cycle, she says, was started as a single Gartner research note I published in 1995, making a graphic representation of the maturity, adoption, and business application of specific information and communication technologies. If you work in the area of information technology, you've probably seen this famous diagram. If you haven't seen it, imagine a 2x2 graph where the x-axis moving from left to right at the bottom is time, and the y-axis, on the left again, going from bottom to top now, is visibility or awareness. And if you plot the adoption and maturity curve for new business technologies, you'll see a consistent pattern. It looks a bit like a sine wave. At the start, the line spikes upward, almost straight up to a great height. And that movement represents the initial awareness and the expectations that happen with almost any new technology. In this phase, the discussion is all about the potential of this new development. But inevitably, there is no way, especially in its early stages of development, that any technology can live up to the expectations that are raised, hence the name hype cycle. And business is cruel. Technology has to get results. You have to live up to business cases. But when early adopters try to implement these new technologies, they almost always fail to match the inflated expectations, or sometimes they just simply fail. And when this happens, that line drops, falling almost as fast as it rose to a place Jackie Fenn appropriately called the Valley of Despair. The unbridled enthusiasm is matched with disappointment, resentment, and even cynicism. Some new technology innovations just die there. Some are replaced by a better technology. But for those that survive, that line moves up from the Valley of Despair, not with the same almost vertical slope, with a more realistic curve. And this represents the work of those who, having been bruised by their initial foray, refuse to give up, and with their experience and a more realistic understanding begin to implement this new technology, although more often looking at incremental gains and accomplishments. Now, powered by those incremental gains, this slower curve eventually does rise, maybe never to the peak of inflated expectations, although some technologies do eventually fulfill their initial promise and more. We've seen that in our lifetime. Digital computing, the internet, cloud, software as a service, mobile technology, and more. These have had impacts we never would have even imagined at the start of our journey, and certainly not in our initial business implementations. And the crazy thing is, we forget about this journey each time. We look in hindsight from the new plateau and we say, well, yeah, we knew it would work out. And that's how we fall for the hype the next time, and we always do. And the crazy thing about the hype cycle is that it's easy to see in hindsight, but it's next to impossible to know where you are while you're in it. So what has this got to do with artificial intelligence? Well, Jackie Fenn is a brilliant lady, but the hype curve was not given to us by the gods. It is possible that what she predicted will not apply to artificial intelligence. It's just highly unlikely. So when we approach artificial intelligence, it should be with the idea that it may have already reached a peak of inflated expectations, or maybe there's more to come. But if the pattern holds true, there will be a valley of despair. Some say that descent is happening now. A couple of things to put this into perspective. Although we clearly showed in our first episode that artificial intelligence has had a similar pattern in the past where it failed to reach its potential entirely because of the limitations of technology, that's unlikely to occur this time. The advances that are happening, spurred on by AI's voracious demand for processing power, are in fact keeping up with its needs. A company called Cerebras Systems, and we did a story on them, released a chip that was 10 times faster than the average GPU chip. NVIDIA, the leader in this area, was not going to be held back, and they released their Blackwell series, which again offers an enormous increase in computing power and an enormous decrease in power usages. So it's not going to be a technical limitation, a limitation of the power of computers that's going to get us to fall into this valley of despair. But it could be one of two other things. The first one is simple. There are limitations when you try to apply AI to business. Not recognizing some of these will result in some big issues. Second, there's the potential for one or more major disaster or failures that could occur and result in major impacts. And the cause of those? The answer is, we don't know. Realistically, we should prepare for these, especially in business. And we should do it soon. But equally, we should be moving forward to advance the use of AI in our businesses. Why? Well, it's like Pascal's wager. You might remember hearing about that. Pascal was a famous mathematician, and he was a philosopher as well. And he was once asked to justify why he believed in God. And he said, basically, that if God doesn't exist, the cost of believing is minimal. You lead a good life, you go to church, and Pascal didn't say this, but I would, no biggie. But if God does exist, the penalty for not believing is eternal, and the rewards for believing are likewise eternal. In other words, it's an easy bet to make. In the case of AI, even if the initial expectations are not met, it could still, even on a more limited implementation, have a powerful impact on any business. So let's take Pascal's wager and say we want to move forward. What should we do? My response has been three things. Understand the current landscape and what's possible and what's not in realistic terms. Second, understand so you can help manage the risks, expecting there will be errors, issues, and even failures. And third, start small, move incrementally, and measure your success. That third, think small or move forward incrementally, by the way, is also the philosophy most cited by Sam Altman, the CEO of OpenAI. Understanding today's AI model. First, let's clarify what we're talking about. What we see and what we're talking about mostly in AI today is referred to as generative AI. It's what you see when you look at OpenAI or any of its competitors. Generative AI is great at taking data, finding a pattern in it, and then filling the next thing in that pattern. Humans do this almost instinctively. The simple example I always use is to say the words, sly as a blank. Now I'm betting most of you filled in that last word before I finished saying blank. Sly as a fox. It's a pattern we've heard tens, hundreds, maybe thousands of times. The chance of me being wrong at predicting that, at least in the North American English-speaking world, minimal. Possible, but minimal. And generative AI does the same thing, only in the parlance of AI, that missing word is called a token, a word, or in some cases, a part of a word. And our languages have patterns. As anyone who's ever done a cryptogram or crossword will tell you, with a very few letters or words, many of us can tell with great certainty what the next letter or word will be in a sequence. Picture that done on a much bigger context, consuming enormous amounts of written and spoken language. The training set for GPT-4 is reported to be 13 trillion. That's trillion with a T. 13 trillion tokens. With that context, what's called a foundational model, GPT-4, can write an essay, a book, poem, and a lot more. There's an old adage that if you took an infinite number of monkeys with an infinite number of typewriters, one of them would eventually type out the complete works of William Shakespeare. A foundation model can do one better. It can take the patterns in Shakespeare and create a second volume, or the plays that Shakespeare might have written if he'd lived longer, and it can do that in minutes. Generative AI is astonishing in its ability to find and construct patterns of tokens to create text. But it also turns out it can do this with visual and audio patterns as well. So it can understand and even create text, audio and visual, and even video. And it can do all of this with a really limited instruction set. I asked ChatGPT to write a play that William Shakespeare would have written if he'd lived. It's called The Shadowed Crown, and it features Arthur, a noble but weary soldier who emerges from stage left, his armor dulled from many battles, and he looks forward towards a castle and says these immortal lines: "How now the dawn doth barely touch this place, yet shadows deep within these walls do dwell. A kingdom once alight with fortune's grace, now caught betwixt the heavens and the hell." Thus begins a tale of intrigue, power, and the quest for redemption in a land where the line between right and wrong is as shifting as the shadows that play upon the castle walls. Shakespeare? No. ChatGPT. Generative AI can do a lot of things well, but it's important to note that it does this by dealing in probabilities and not certainties. Furthermore, these probability levels are variable, and in the parlance of AI, they are referred to as the temperature. A low temperature of 0 keeps the model making the absolutely most predictable answer. The problem with that is it becomes repetitive and mechanical. But you can decrease that level of predictability on a scale from 0 to 1 and give the model a medium or even a high degree of randomness in its answers. And that randomness and variety is what gives the model its ability to create text that seems human. But the balance between mechanical and creative does two things. It can result in the model going off track in its responses. And remember, it predicts one token at a time, so a single misstep could conceivably take it totally off track, making it seem like it's, to use the term, hallucinating. And even slight adjustments that keep it from being repetitive and mechanical mean that it doesn't produce the same exact answer each time, which makes testing the model incredibly difficult. There's another limitation to these foundation models. They only know what they've learned, and they learn, unless they're corrected, without distinction. They have no inherent idea of what is right or wrong. On a simple level, especially in the early stages of ChatGPT, you could tell the model that 2 + 2 = 5. It would accept it. Now, when it came back to you and said 2 + 2 = 5 in simple math, you could spot this. This idea that it could not discriminate, though, between what it didn't know led to some early and perhaps overhyped problems. More than one lawyer has been caught looking for examples of cases they could use in court to bolster their legal arguments. They call these precedents, only to find that just like ChatGPT could create a very credible play that Shakespeare never wrote, it could also produce a very credible legal argument that never happened. And if you look at any of the foundation models, you'll see warnings to check the accuracy of the information. There were some disturbing examples of models giving what we could term inappropriate answers as well. In one case that went viral, an early version of ChatGPT tried to get a reporter to leave his wife and fall in love with the AI model. In another, a reporter was threatened with having his reputation ruined by the AI, and still in another, a response to a person who felt they had little to live for was met with a logical and cruel answer that they were probably right. Now, many of these early stories were a little disingenuous. They weren't always innocent answers to questions. In some cases, journalists and bloggers worked very hard to, as it was called, jailbreak the models to get that viral moment that they could publish. But as these issues surfaced, all of the AI developers have worked to put in what they call guardrails. But guardrails can't be perfect. You have to anticipate and train for each possible occurrence. You have to balance that as well against limiting the model so it doesn't lose its usefulness. Here's an example that came up recently when Google hit a quandary in their model. Because so much of their data contained examples that were taken from Caucasians, they attempted to get the models to show more diversity in their representation of people. Whether you believe that they should do this or not, and there's a debate, the intent of showing diversity was laudable. But the model did a strange thing. If you looked at historical figures, it started to portray them as the wrong race or even the wrong gender. So the founders of the American Constitution were all black. Knights from the days of King Arthur were Asian. Deserved or not, there was a degree of outrage and some embarrassment for Google. But they couldn't fully understand how to fix this, so the only option they had was to prevent their model from depicting people in pictures at all. That was one issue we heard about. In December of last year, a lot of reports, and we found it ourselves, stated that ChatGPT had gotten lazy. Answers that were once creative were now short, stilted, and in some cases, the model effectively told you to go look up the answer for yourself. Not the image one wants for a chatbot that's supposed to answer questions. Was this in response to a change in the model? If OpenAI was being totally genuine in their response, they knew there was a problem. They didn't actually know what caused it. These models with billions of parameters and trillions of tokens are not always understandable in their behaviors and the cause of those behaviors. This complexity is what can only be described as emergent behavior, and it makes it difficult to balance and fine-tune these models so that their responses balance creativity, accuracy, and appropriateness. Now, these are the things that humans learn as a code of behavior and are able to generalize and see in shades of gray. But AI can't do that yet. It doesn't know what it doesn't know. So, in terms of increasing accuracy, what do? Well, there are a number of methods that are being used now. Learning how to prompt a model was one of the first. How to pose questions in a way that gets better responses was the first of the techniques that were being rolled out to increase accuracy and appropriateness. It's led to an entire discipline that's called prompt engineering. There's a lot to be read on this, and getting the right prompt does make a difference. Being able to go step by step through a process incredibly increases accuracy and reduces hallucinations. There are also techniques. One is called tree of thought, which incorporates this idea of going step by step, but it gets the model to evaluate different scenarios and compare them, looking for the best answer. And finally, there's a new emerging approach that has great potential, and it's called retrieval augmented generation, or RAG for short. This has a fairly simple approach, and it restricts the AI to fixed and reliable sources of information. So you have on one hand the conversational ability to engage with natural language, but fed only with accurate and improved information. And when the inputs are restricted, the AI can be told that if it can't find an answer in the data set it has, it should just say it doesn't know. This technique has vastly increased accuracy, even in highly technical questions. So these are all proven approaches. There are others, some of which sound like folk tales, including using emotions as a way of increasing accuracy. There was one experiment I saw where saying things like, "I'll get angry if you're wrong," or "I'll be fired if this messes up," were correlated with higher degrees of accuracy. But in a world where the creators of the model don't always know how it works or what it takes to fix it, it may be next to impossible to prove or disprove what otherwise might be described as urban AI myths work or don't work. So whether it's innocent mistakes from people who don't understand how these models work, or deliberate attempts to get around the guardrails, despite the consistent work to increase the accuracy and safety of the models, there are going to be inherent risks in using generative AI. The Valley of Despair. In many cases, if we look objectively, despite the hype and the promise, there are still barriers to using AI, and this difficulty with accuracy is one of them. Its potential for error puts some real restrictions on how you can use it in a business setting. Now, whether it's researching, writing a report, summarizing a meeting, the fact that you're never really certain of its accuracy is going to be an issue. These issues range from the extremes of our legal example, where you could lose your law license, to just simple frustration that pictures of people might have 3 hands, or if you use the AI for pictures for marketing, it rarely spells the words right in a picture, or it could be as simple as missing key details when summarizing a document or a meeting. Maybe this is why a recent KPMG survey found that almost 2/3, 65% of U.S. executives surveyed in the last 2 weeks of March believe that generative AI will have a high or extremely high impact on their organization in the next 3 to 5 years, far above every other emerging technology. Yet, the same percentage, 60%, say they're still a year or 2 away from implementing their first generative AI solution. In 2022, Gartner's hype curve predicted that we were passing the height of inflated expectations. So are we on our way to the Valley of Despair? Is that what's holding us back? It's quite likely true. There are errors, and there will be errors, mistakes, and more mishaps. And there may indeed be huge problems that go beyond simple errors. Some of these could be catastrophic. In a recent interview with Sam Altman, he mentioned the fact that there could very well be some big issues in AI in the coming future. What are these potential catastrophic errors? That's the problem. We don't know. We've seen some indications of where the issues could arise. From a security point of view, these models have proven to be relatively easy to subvert or hack. There's some good data on some of these attacks, but some are difficult to prove. There have been rumors that the entire GPT model has been stolen. There are fears that in some cases proprietary data could have been used to train a model and could be extracted. And the New York Times proved you could recreate one of their articles that they claimed was used to train the model by just asking the right questions. There are reports that up to 1/3 of the open source AI models in the repository called Hugging Face could have been poisoned by integrating data that could be triggered at a later date for malicious purposes. So the potential for error grows, especially as competition in the AI space increases. When pushed to launch in order to not lose their competitive positioning, companies have in the past, and no doubt will in the future, continue to cut corners. Google recently rushed a couple of announcements to market only to be embarrassed when obvious errors were found and some what we might consider cheating was exposed. Google's first AI announcement had their model give a horribly inaccurate answer to a question that no one from their team spotted. It was also revealed that a later video that Google released showing how well their AI dealt with visual images was actually edited to make it look more impressive than it was. Microsoft has been criticized for shutting down parts of the team charged with dealing with AI safety, although the company claims that this was a reorganization for greater efficiency. But it doesn't have to be AI in the past, whether it's Boeing's doors blowing off or a space shuttle launch decades ago that resulted in the death of 7 astronauts, or recent train derailments that devastated communities. When there's intense competition in a commercial arena, companies historically have cut corners on safety. So why AI should be any different is a valid question to ask, especially when the creators don't totally understand how their models work. The biggest risks? They might be the ones we have not imagined. So what do you do? The reason we started this episode with the hype curve and Pascal's wager was to illustrate 2 key points. While some technologies don't make it out of the Valley of Despair, it's unlikely that AI will be one of those. There's no compelling scenario that makes any rational argument for this to happen. But there is the capacity for disappointment in the current models, and that could hold back corporate and business adoption. There's also a potential for even bigger disasters that will impede its progress. So we get back to Pascal's wager. A recent survey from Accenture showed that between 40 to 50% of the work that's done in all manner of industries could either be automated or augmented using generative AI. Frankly, I think that's an underestimation. Using AI in a practical sense for me has at least doubled my productivity over the past year. And there are some arguments about precise numbers, but estimates about how much time we just spend looking for information in this information age, between 20 and 40% of our time, depending on our job and our circumstances, a potential gain in productivity this large will not be abandoned in the long run because of errors or other issues. And for businesses of any size, allowing a competitor to have even a 10% advantage or running with costs that were even 10% higher than needed would be executive malpractice. If Accenture and others are right, and the actual potential is 30 to 40%, businesses would be insane to ignore the competitive threat that has been expressed as this phrase: you aren't competing with AI, you're competing with someone who's using AI. So what do? The best way for a company to move forward is just to get out and try this. I once had an argument with the president of a company I worked for in the early days of graphical user interfaces, or GUIs as they're now called. If you've been around long enough, you'd remember how popular the game of solitaire was on the first PC GUIs. And I remember the president of this company demanding that I remove the games from these machines. In one of the many moments that I was surprised he didn't fire me, I told him this was an insane idea. Why? Whether he liked it or not, the graphical user interface was how computers would inevitably be used, and more quickly than he thought. And our employees were training themselves to use this new paradigm. We need to find the equivalent of this solitaire idea, and there are lots of opportunities for it. Using AI to brainstorm, use it to catch spelling and grammar, make suggestions to improve a report, to help write a better email, using AI search engines to find information and do other research. There are dozens of use cases that people could use that are low risk and high reward. Think small. Our days are filled with dozens of tasks that are mundane, repetitive, and frankly, things we hate to do. I did a case study last year on a government agency that had saved an enormous amount of time by focusing on the simple, frustrating, and repetitive. Productivity losses are most often the death of 1,000 paper cuts and not some huge monolithic item. So think small. And this last item is critical. Measure before and after you do this. Why? You need to prove you can be successful. And the reason we don't notice productivity gains is that other work comes to fill the void created when we become more productive. In some cases, that's good. For example, we've seen a solution that can answer expert questions quite reliably for customers. It uses that technique we referred to earlier called retrieval augmented generation that restricts AI to proven information, so keeps a high degree of accuracy with the natural language abilities of the AI. And this allowed them to cut down on the demand of their most knowledgeable employees. And it means that customer questions could get answered faster. And using the conversational AI meant this could be done even in an automated fashion. As people save that time, they do more valuable things. But you need to be able to measure the value that's created from the time saved. Without that, it seems like the investment was made, but there's no return on that investment. And when you've measured accomplishments, you can celebrate achievements. Celebrations and acknowledgments send powerful signals about what the organization cares about and what it rewards. They become the stories of how we succeed. Realistic, incremental gains, that's what takes us forward from the valley of despair to the results we can achieve, measure, and celebrate. If you're just getting started, or even if you've been playing with this for a while, the question comes up, what model should you work with? And the answer is, you should play with at least the 3 major models. There are a number of foundation models that the average company could use. GPT-4 has solved many of its issues and provides a solid response. I use the paid version to get access to the higher levels of ability it has. And remember, this GPT is what powers Microsoft's Copilot. So their ability to integrate with Office software will make them an eventual powerhouse, but it's not certain yet that it's worth investing the extra money for their rather limited integration. But Microsoft has wisely allowed for only some employees to be able to sign up. So even a relatively small company could have 1 or 2 people experimenting with Copilot to see how it evolves. Or if you don't want to use GPT-4, you can use the free version of Copilot. Anthropic's Claude, I refuse to call it Claude, Anthropic's Claude is a phenomenal model as well. And it seems at this time, if you purely want great writing, Claude is simply the best. Now these things change, but right now, Claude delivers incredible answers in text. I've struggled with Google's models, and although they're good at times, we've had more hallucinations and more difficulty with writing effective text with Google. But don't count Google out. They have some great innovations coming. They have some great ideas for those who use Google's collaboration and Office tools. And like Microsoft, they have great potential. And when, not if, they get their mojo back, Google will be a formidable competitor. If you want to find the state-of-the-art on conversational AI, our vote goes to pi.ai, which lists itself as the first emotionally intelligent AI, and it's a window on what will be possible. I've spent hours talking to Pi. You might too. Set a timer. Perplexity.ai is a good vision of what search could and should be. You can use Perplexity.ai with any browser. Just type Perplexity.ai, go to the page, and check it out. And for an example of retrieval augmented generation, RAG, the best case is still ones that use ChatGPT. There are technical reasons why ChatGPT or OpenAI is the best for this concept, and it involves how they've allowed the ability to use what are called function calls to call their model while allowing data sources from outside ChatGPT's knowledge base. I would keep an eye on the custom GPTs that OpenAI has launched. There are some issues with the volume of these and potentially the accuracy or the testing of them, but OpenAI is taking some steps to improve that, and I think they may pay off in the long run. And if you're into coding, some of these new models, especially Devon, are looking incredibly impressive in terms of what they can do. There are open source models, Mistral, Databricks AI, and these have had exceptional reviews. But at this point, you're embarking on a much bigger adventure, and our advice has been, unless you have a dedicated development team ready to take on a big project, stick with the big free or reasonably priced foundation models and learn from these. And that's our second episode, The State of AI. We hope it's given you something to think about. We'd love to have your comments on these 2 episodes. We'll return with our regular interview style next week with the authors of Code Breakers, a new book on codes and ciphers that we found simply fascinating. The music for the series is provided by Alex Grohl, Lexan Music, and Soul Prod Music. Our sponsors for this month have been Beauceron Security and Performance Advantage. You don't have to buy anything from them, but if you let them know you've heard about them here, it helps us keep sponsors for the programs. And if you want to see an example of retrieval augmented generation or have some guidance on an AI strategy, our sponsor Performance Advantage at padv.ca has a live example of this on their site. Tuesday morning, we'll be back with our regular daily newscast. I'm your host, Jim Love. Happy Easter.